Login accepted.
Okay. Hello, everyone. I really appreciate you to coming here. I know it's not that late, but I guess it must have been tiring for you to spend your entire day here. So let me entertain you for your last 30 minutes of being here. Today I'd like to talk to you about Elm and basics of functional programming. And let me start this presentation by a little story, a personal story of mine of how I started with functional programming in the first place. So it was around, I don't know, 2 years ago, in March 2019, a year before all this awful pandemic hit. And I was on my local TypeScript meetup in Wrocław. And the theme for that meetup at the time was functional programming. And there were two talks. One of them was about Marble.js, a library for creating backends with functional reactive programming, which is really a whole different set of paradigm than just functional programming. And another talk was about how static typing of TypeScript helps us with solving basic functional programming concepts. So what I remember from that talk was that I understood maybe 10% of what was said. And that was because of two reasons. One of those was because at that time I had maybe 6 months of experience in TypeScript, so all those advanced topic was still unfamiliar to me. And the second one was that I didn't even know such thing as functional programming even existed, so all those new concepts and buzzwords were just confusing to me. But I remember this feeling of excitement and rush and feeling of challenge that I had to just rush back home as soon as possible to just sit in front of my laptop and just read some articles, video tutorial, something like that, to just understand these concepts deeply, because it was such a new concept to me. So you can treat this presentation as a summary of my first few months of learning functional programming with the JavaScript ecosystem. And I'd like to tell you why I think that Elm is a delightful language for learning functional programming. Hi everyone, I'm Kajetan Świątek. I'm a front-end developer at SoftSurf. You can find my work at Twitter on KajetansW Twitter handle and on my blog kajetan.dev. Today I'd like to start with explaining to you why should you even be interested in functional programming, what exactly is Elm, the programming language, and why should you at least try it. Then I wanted to compare Elm to the most mainstream solution there is for static typing for JavaScript application, and that is TypeScript. And then I'd like to end with showing you the alternatives to Elm, so other FP languages that compile to JavaScript. So why should you even be interested in functional programming? If you ask any expert functional programmer about what is the basic building block of functional programming languages, those would be pure functions. And pure functions are called like that because of two reasons. One of those is that for every input, they always return the same output. And the second one is that they do not perform any side effects. And I'd like to define side effects as any operation that require grabbing some external resource. So that may be grabbing data via HTTP call or database query, or even using a variable that is outside of the function scope, which is possible, for example, in JavaScript. So you can ask how we can compose, how can we create our functions and compose them into our programs without any side effects? And there is even a running joke in a functional programming community that without side effects, the best thing we could do with our programs is to heat up our laptops from all those computations. So programming languages like Haskell and Elm have their own solutions for that problem, and I'd like to present a solution for Elm in a couple of minutes. Then there is immutability. Let's imagine we have a data structure that would like to update in some way. So for example, we have an object and we want to update a field in it, or an array or list, and want to add some item to it. With mutable data structures, we would just grab some existing structure from some reference and just update it and leave it where it is. With immutable data structures, we would have to create a whole copy of the entire structure with the updated piece of it. And you can imagine that immutability is quite a difficult topic to reason about. And because it has its pros and cons. Pros in terms of our programs being more deterministic, more predictable with immutable data structures. But cons would be that if we implement our immutable data structures in a naive way, we can impact our programs badly in terms of performance. So I'd like to point out that most of the functional programming languages that just use the concept of immutability. Then there is easier testing. Easier testing is just a result of those previous 2 points, so pure functions and immutability. And if you have those combined, it results in programs that are more deterministic, more predictable, and also are easy to test because, for example, we can mock stuff and easier and, like I said, predict behavior. There's also constant growth. Constant growth on many layers because it can be on a layer of learning resources for functional programming. You don't have to anymore go through 2,000 pages books about category theory or math concepts or something like that to learn functional programming today. There are a lot of people who are eager to share their knowledge. They create tutorials, articles, etc. It's never been so easy to learn functional programming. Also, constant growth in terms of career development because there are more and more companies that are investing in functional programming languages. And some years ago, we wouldn't even imagine Haskell as being a production-ready language, but here it is. And I wouldn't compare this job market to the most mainstream ones, like for Java programmers or JavaScript, Angular, React, etc. But it's getting better and better. And the last thing is that learning functional programming just broadens your mind. If you have object-oriented programming background like I did, just let me tell you that when I started learning functional programming, I felt like just five-year-old, like a person who just started with learning programming altogether. And it was a wonderful feeling of challenge. And I wouldn't dare to say that you have to learn all those intermediate or advanced concepts or learn math around functional programming. But even learning basics of functional programming would launch your career into a stratosphere because all those mainstream programming languages and technologies start to adopt basic functional programming concepts. So now, what exactly is Elm? Oh, that's unfortunate. Okay. Yeah, that was supposed to be a screenshot of the main page of Elm language, and it says that Elm is a delightful language for reliable web applications, and that's how my talk's topic was constructed. And you can say that Elm is a language that compiles to JavaScript It is meant for developing web applications. So we cannot create like systems in it, mobile applications, backend, etc. Only only for the web development. So why should you at least try it? Okay, next missing images. All those because of the advantages of FP World that I've already mentioned. So pure functions, immutability, easy to test, constant growth in terms of development of language and tooling around it, and also learning it broadens your mind. Okay, let's imagine we have two worlds. The world of easy programming languages and hard programming languages. And of course, I'll be comparing only three of those, sorry. So it would be just comparing three different technologies, and also like comparing languages in terms of being easy and hard is really subjective, because a person who has 6 months of experience would be adapting to a new technology a lot slower than a person who has 10 years of experience. But let's just stick to the general statistics of the, like you could say, IT population. So I guess there will be more missing images. Yeah. Yeah, maybe I'll do that. Can I do that? So, okay. Oh, yeah, thank you. Sorry for not being prepared properly. That's just evil. I'm trying to not pass out from stress. Yeah. Mm-hmm. DVX PL
2021.
2021. I have 19 here. 21.
That's 21 for sure. You have old one.
Okay. Okay. Sorry about that for those problems, but let me just jump back to. So let's imagine that the easy language would be JavaScript. Of course, some of you would say that JavaScript isn't that easy, but let's just stick to the basics of the language and just starting being productive with the technology. And comparing to JavaScript, we would tell that the hard language is Haskell. Even comparing Hello World examples, in JavaScript you have just one line invoking console log function, but with Haskell we have already touching some interesting abstractions like monads, and to know monads you have to know applicatives, and to know applicatives you have to know functors, and to know functors you have to know semigroups, etc., etc. And even to run and understand easiest example, you have to know all those abstractions. So when in this diagram, in those two worlds, the elm lives, I think somewhere in the middle. because it has some familiar syntax and familiar things from JavaScript, which makes it even easier to learn for JavaScript developers or people who have already experience in JavaScript. And it borrows some interesting concepts and abstractions from Haskell, like the maybe type, result, and pure functions, immutability, and so on. What's also interesting and distinctive about Elm is something called the Elm architecture. And this architecture can be compared somewhat to existing state management solutions like Redux or NGRX for Angular. And everything starts with the model. Model can be is the representation of data that flows through our application. So it is something like state in state management solutions. So model is used to render a view, and the view is represented in Elm as a function that is also called view and takes as an argument the current model and returns a template that should be rendered to the screen. And inside of view, in our template, there can be some messages bound to our events or user actions. We can imagine, for example, a button with the on-click event, and to this on-click event, there can be a message bound. And message is something like action or actions in state management. And the messages are where the message is run, it can be captured by the Elm compiler, and the update function is invoked. And update is a function that takes the current model and the message that was caught, and it creates in return a new model, so a new state. And if you squint your eyes, you could see that this entire diagram is pretty similar to the Redux or NGRX and other state management solutions. And if the fun fact is that Redux in itself was adopted from something called the Flux architecture. And the Flux architecture is based on the Elm architecture. So you could say that the Elm architecture is somewhat a grandfather of Redux. And what is distinctive about the Elm architecture is something called the Elm runtime. You could say that Elm runtime is something like a black box that performs side effects. So it is Elm's solution to dealing with side effects. And all we do as developers, we create something called commands that communicate with runtime. For example, command to invoke HTTP GET function to grab some data. The Elm runtime does it in the background, and in its due time, it returns some message with a payload. And the message is then processed again by the update function and creates a new model. So in this example, I'd like to show you a basic, the most basic example of the Elm application, which is a counter application. So we have a counter and two buttons that are incrementing and decrementing our counters. So first thing we do is to create a type for our model, which is just an alias for existing integer type. Then we use the built-in init function to initialize our model. In this case, that would be 0. Then we can write our view function. So it takes a model and returns a template. And all HTML elements in Elm have a structure of being a function that takes a list of attributes and a list of children. So in this example, we have a div that has no attributes and has a list of children that are button, text, and another button. And you can see that to each button there is a message bound to the on-click event. And how do we define our messages? They are defined as something called a sum type. Some of you who are familiar with TypeScript or can find it familiar. So sum type is something like sum of two possibilities. So message in this example can be a sum of two options. It's either increment or decrement. And then we have our update function that takes a message that was run, the current model, and uses something called case expression, something similar to just a switch case expression in JavaScript for our message. And if the message is of increment, we return incremented model, and if we decrement, if it returns decremented model. What's interesting about Elm is that all case expressions must be exhaustive. And that means that if we were to remove the line, for example, for decrement, the compiler would complain about it because we have to handle all possibilities of the value of the message, which is quite cool, I think, because it forces developers, I think, in a good way to think about all possibilities that go around in our programs. So the next thing is something that that absolutely sold me on Elm, but it can sound like a marketing catchphrase. But Elm promises something like no runtime errors and no null or undefined. And this, like I said, completely sold me because I was already infuriated with all those unpredictable errors due to null or undefined being there. And for example, how Elm deals with no runtime errors. If we think about it, a lot of runtime errors come from the fact that there can be some unpredictable data coming to our applications. For example, if we are using Google Maps API or Facebook API, or we are using our backends, but the backend team is completely a different entity. And there can be some cases where the API, I don't know, changes in some way. And that change may affect our applications in a bad way and can lead to some bad user experience. And what Elm does is, again, I'll use word force, but force in a good way. It will force a developer to think about both success cases and failure cases. Because in languages like JavaScript or even TypeScript, we can just cover success cases, for example, do a fetch and just pray for the best, but not in case of Elm. So in this example, we have basic function getHero, imaginary function that gets some imaginary data about our heroes. So it takes an URL and invokes the built-in get function from HTTP module. And it takes an URL and something called expect. And expect allows us to communicate with Elm compiler what exactly is the data that we expect from the result of this fetch. So here we use expect.json method, and then we bind to it a message that should be sent as a result of this fetch. And then there's something called hero decoder that is passed there. This is something, the abstraction called JSON decoder, and JSON decoders just do exactly as the name says. So it is a decoder for JSON values. So there's a lot of atomic decoders for primitive types in Elm, so string, booleans, integers, etc., and decoder for composing those into bigger decoders for bigger data structures like object, list, etc. So in that way, we communicate with the compiler how exactly should Elm decode those data. In terms of dealing with no null or undefined, or just the situation where the value just isn't there, there's some useful type called maybe. And maybe is, again, a sum type. So a sum of two possibilities of value just being there, so just A, or nothing. And for example, we can use it in function for sanitizing user input. So first we trim it. We trim the input, and there we use a built-in toInt function to parse the string to integer, because not all strings can be compared to integers, but all integers can be parsed to string. So we do not return integer, but a maybe of integer. So parsing can be successful, or it can be not. Another way around, we can use maybes to get some default values for our use some defaults for our values. Then we just take the maybe type and we use the case expression to check. If it's just some value, we return this value unwrapped, and if it's nothing, we return some default value we can use. So the next thing is Elm versus TypeScript. I think it's fair to mention that all those two technologies are quite different, because Elm is an independent language of its own that compiles to JavaScript, but TypeScript is like a superset of JavaScript. So it's all the valid JavaScript syntax is valid TypeScript syntax, but TypeScript adds a little flavor to it. So to start, Elm prevents runtime data inconsistency. So, like I said, API changes if you use some external API. But TypeScript and JavaScript do not force our hand into that. And I think that this disadvantage of TypeScript comes from the dynamic nature of JavaScript. There's, of course, no null or undefined. Again, this disadvantage, I think, comes from the JavaScript, and there is nothing, I think, TypeScript can do that unless it provides runtime typing, but I think it's out of scope for this project. Elm provides immutable data structures, and I think it's fair to mention that TypeScript, that mutability, this is not a disadvantage with TypeScript, because mutability can be also good when used properly. For example, it can impact our performance in a good way. But if you are interested in using immutable data structures in JavaScript or TypeScript, there are libraries that do that, for example, Immer. There's an interesting concept in TypeScript, and that is type any or unknown. And those were created for TypeScript for cases where projects are migrating from JavaScript to TypeScript, so it would make those migrations easier. And of course, because of the strong and strict typing in Elm, there's no such thing. All data structures must have concrete types. And of course, because all of that, Elm prevents poor typing from third-party libraries. We can imagine, I think there are no such cases, but we can imagine a successful JavaScript library that community wants TypeScript support for it. So the author of the libraries just change the extension of files from JS to TS, and all of types are any. Tada, we have TypeScript support. It's not possible in Elm because of the strict typing. And I think both of those technologies are easy to adopt in existing projects, both in a different way. In Elm, if you want to adopt Elm and make it a part of your existing application, for example, React or Angular application, you have to install the Elm compiler, set up a basic project in your repository, and point exactly in which HTML element you'd want to have your Elm application rendered. In TypeScript, there's also a pretty easy a pretty easy solution for migrating from JavaScript to TypeScript. It's quite easy in theory, but it depends on the size of the project. You just have to change the extensions of files from JS to TS and gradually add typing to it. So to sum up this section, I'd like to also point to you to some interesting libraries for TypeScript that let you write in functional programming or use functional programming concepts. First of those would be FPTS. I think it's the largest library there is, and with the largest ecosystem and community. There is also something like a new kid on a block, FXTS. And FXTS has a completely different approach than FPTS, but and it may sound familiar to some of you because it's a port of the ZO library for Scala that provides some functional programming concepts to Scala. So at the end, I'd like to point you some alternatives to Elm, so other FP languages that compile to JavaScript. So first would be Rescript. You may know it as BuckleScript or ReasonML. It's a programming language that is developed by Facebook. Then there is PureScript, my personal favorite. That is a purely functional language that is inspired by Haskell. It's so much inspired that if you know one of those, you pretty much feel comfortable with the other. And there is Scala.js, which is like a library or framework for creating web applications with Scala. If you'd like to learn by example, there is something called Elm Survey app that I've created for the sake of this presentation. And this is an example Elm application that serves you a survey for this presentation. So I would really appreciate if you just go there and take 3 minutes of your time to complete this survey. There's also a cool initiative that is called Real World Example App. And this is a collection of repositories that implement, of projects, applications that implement the same application, a clone of the Medium platform. And so you can learn by, for example, if you know already Angular and we would like to learn React, you clone 2 of those repositories and learn by comparing how those 2 were implemented. So you can also clone like Angular repo and Elm repo and compare. There is also an interactive playground full of examples in the main Elm website. So there is also some list of learning resources. I'll make sure to post it on, for example, on my Twitter after that talk. Also a link to the entire presentation. So there is a beginning Elm, which I think was the most useful to me when I started learning. So it's a really comprehensive guide to basics of Elm, and along with learning, you create some entire Elm application. There's also official docs, which are quite cool to read. There's also Elm, so just a list of all resources there is about Elm. And the link to presentation by Ivan Czaplitsky. Ivan Czaplitsky is the creator of Elm, about some initial design decisions of Elm. And that's it. Thank you very much for listening, for attending. You can find my work on Twitter, on my blog, and don't forget to complete the survey. Thank you very much.